What's poppin', dogs? Mr. Allen here. I'm about to graph this quadratic function using transformations. All right, so a different approach. Well, first off, for my transformations, I need to know what my parent function is. And for this one, we'll call it f of x, and that's going to be my quadratic, my x squared there. All right, so there's my parent function. Let's go ahead and plot some points for my parent function. Well, if I plugged in 0, I got 0. If I plugged in 1, I get 1. And the same would go if I plugged in -1. I might have some symmetry going, right? That's my axis of symmetry there. And then if I plugged in 2, I'd get 4. And the same would go with -2. Okay, so those are my points of my parent function. I'm not going to actually connect the dots. I'm going to leave that and then use those to plot my new g of x function right here, which we'll do in the wonderful color pink. All right. So in order to do this, in order to analyze this function properly, I actually have to factor out this 2, whether or not it can come out of 6 nicely. Even if this is like a 5 here, I just still have to factor out a 5 and be left with like 6/5. It's terrible, but it is what it is. All right, so I'm going to factor out that 2. No matter what this number is, it's coming out when it's on the inside of my function. So now I have g of x equals parentheses 2 parentheses x plus 3 close close squared minus 3. There's my function I'm going to analyze. This allows me to see my horizontal transformation here, which would be left 3. Over here it looks like it's 6, but that's not the case. All right, so let's write down our transformations. I see 1, 2, 3 of them. In here on the inside, it's going to be horizontal, and we got to flip it, right? We got to flip it and think opposite there. It's going to be a horizontal compression by 1/2. This one here, we're going to be going left 3, got to think opposite on the inside, but then on the outside, normal stuff. We're just going down, yellow and timber, 3. Dope. All right. Now I got them, I can apply them to the points. So for my 1 at 0, 0, if I horizontally compress that by 1/2, that's not going to do nothing, right? It's going to do nothing. So then I'm going to go left 3, boop, and then go down, oops, there we are, 3 as well. Right there. Beautiful. That is my new vertex. Now my next one, I got 1, 1. Horizontal compression. Well, 1, my x value of 1, times 1/2 would be 1/2. So I'm at 1/2 right here. Then I'm going to go to the left 3. So 1, 2, 3, I'm right in between there. And then I'm going to go down 3. 1, 2, 3. We're on nice points there. There we are. We're right between them. Okay? So this thing's going to get a little bit skinnier. All right. Same would go with the other one. I can actually just reflect that over my axis of symmetry. So I'm right about here. Okay. Last one up here, and then I'll reflect it. I'll use my axis of symmetry. I'm over at 2, 4. Well, horizontal compression would put me at 1, so I'd be right there. Then I'd go left 3, 1, 2, 3. I'm on this point right here, and then I'm going to go down 3. 1, 2, 3. Right here. And then I'll reflect that over my new axis of symmetry, which is right here, guys. There we go. Reflect it over. I'm right there. So now my new graph, a little bit skinnier, wee, and a little bit, woo. There is my horizontal compression by 1/2. Squeezes it in, right? It shifted left 3 and down 3. That checks out from those points right there, and that's dope.